Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, I will finish chapter 5, which is about modeling objects, and I will explain the scenarios and sequence diagram. Let's start with the scenario. What's a scenario? Scenario is like a story about the feature or about the functional requirement or the interaction, and it involves a complete description of the requirements or of the interaction or feature. Scenario consists from let's say 5 basic elements, which are the start state, a flow of event normally, which is sometimes called basic path, and possible faults and handling, and other activities and finish state. In start state, we need to outline what the system and user expect when it starts, the state that should be reached at the starting point. Flow of event, or sometimes called basic flow, which describe the normal flow of events. Possible faults and handling. Here we need to describe and outline what kinds of faults or let's say exceptions that might occur and how we can handle these errors or faults. Other activities. Here we need to give more clarification about concurrent activities that might be occurred during this interaction, and the finish state is going to describe the state of the system after finishing the interaction or the feature or the requirement. And the scenario could be written as a text and supplemented by diagrams, screenshot, tables, etc. And there are more structured approach, such as event scenario or use cases. An example of text scenario. Let's say the requirement or feature: a user of the library system printing an article in a medical journal, free for subscribers and charge fee for others. Let's write a scenario for this feature or this requirement. As I said in the previous slide, the scenario consists from 5 elements. Let's start with starting state, or let's say initial assumption. The user logged on the library system and located the journal containing the article that need to be printed. Normal activities or basic path. The user selects the article. The system prompts the subscription code or method of payment if not a subscriber. The user fill in a copyright form and submit it. The PDF version of the article is downloaded to the library system working area on the user's PC. The user prints a copy on a selected printer. And specify what can go wrong. Might be the user may fail to fill in a copyright form correctly. So what we need to do: rejected form. I think this is a spelling error from form, if not corrected in second attempt. Or maybe the payment may be rejected by the system because of expired credit card, for example. User request is rejected. Might be another exception could happen. The download may fail. The system retry and until success or termination by the user. And might be the article may not print if flagged read only. In this case, it's deleted. And we can add more, let's say, likely errors that might occur. Activities might be there's like simultaneous or concurrent download of other article is taking place on the system. It could be more than one user working on the system at the same time. Then the system state on completion. What the state of the system after completing this requirement. User is logged on. The downloaded article has been printed and deleted from library system workspace. Now let's start with sequence diagram. Sequence diagram shows the actors who are involved in the interaction, the objects they interact with, and the operation associated with these objects. The sequence diagram consists of actors and objects, and the relations between these objects and actors represent the operations or methods. Sequence diagram or collaboration diagrams in the UML are used to model the interactions between objects. Here we use to model how the objects are gonna behave according to specific feature or requirement or interaction. We need to show what are the methods that are gonna be executed among different objects in order to complete a specific task or functional requirement. So, what do sequence diagram model? It models, we use sequence diagram to model the objects in order to capture the interaction between the objects in the context of a collaboration, and show object instances that play the roles defined in a collaboration. Show the order of the interaction visual by using the vertical axis of the diagram to represent time of what messages are sent and when. And from its name, the sequence shows the sequence of methods that should be executed in order to finish the requirement. In sequence, there's an order, and it shows the elements as they interact over time, showing interaction or interactions in instances, and do not show the structural relationships between objects. Here we don't model or represent any kind of structural relationships between these objects, such as inheritance, dependency, aggregation, and so on. And it models a high-level interaction between active object in the system or object instances, either model generic interaction showing all possible paths through the interaction, or specific instances of interaction showing just one path through the interaction. It captures high-level interaction between user of the system and the system, between the system and other system, or between subsystems. Here we can say that the sequence diagram could be used as a generic model to show the interaction between objects and between other systems, or we can go on details for each type of this interaction. Sequence diagram consists mainly from frames, lifelines, messages, and focus control, and more. I think here we need to just focus with the message and focus. The sequence diagram frame, which we use to create a boundary for specific type of interaction. Okay, as I said previously, the sequence diagram show the order of methods or actions that should be executed. So it should, here there's a time which represent as a vertical axis. The vertical axis represent the time proceeding or progressing down to the page. The time here, it's used to represent the order, not the duration. We don't model the duration of the process or the object. We just show the order. The objects are represented or shown on the horizontal axis, which shows the elements that are involved in the interactions. In other words, we need to show the objects that are gonna be active, or let's say involved in order to perform or to execute a specific functional requirement. And we list the object from left to right according to when they take part in the message sequence. But you can change the order of the objects, but it is good practice to put the first object involved and the second as well, in order to make the model more clear and simple. The lifeline of the object. As I said, sequence diagrams are organized according to a time, and the time here represents the order. Each participant, which means each object, has a corresponding lifeline, which is a dotted line, a dotted vertical line. Each vertical dotted line is a lifeline, representing the time that an object exists. Each dotted lifeline, it might contains a thin rectangle on the lifeline. This is called focus of control or execution occurrence. What is execution occurrence? It represents the period during which an element is performing an operation. The top and the bottom of the rectangle are aligned with the initiation and the completion time. So the top means the initiation and the end means the completion time. An event is a point in an interaction where something occurs. You can see here we have lifeline 1, which represents, let's say, represent object 1, and we have lifeline 2, let's say it represents object 2. There's a message goes from lifeline 1 to the lifeline 2 and return message that goes from lifeline 2 to the lifeline 1, and this is the starting and ending point. Message or signals on a sequence diagram are specified using an arrow. The arrow means the message, which means the function from the participant message caller that wants to pass the message to the participant message receiver. A message or stimulus is represented as an arrow going from the center to the top of the focus of control, which is execution occurrence of the message on the receiver lifeline. Of messages or notation for messages for synchronous assign reply. We don't go in details regarding these message types. Just let's take the one kind of a message. This is an example of sequence diagram about issue of electronic items. As you can see here, the actor, which is the library user, and you have a cat double colon catalog. A cat means it's an object. The catalog is the class name. which means the ACAT is the object created from class called catalog. On the library item, there's nothing before the double colon, which means it represents the class. Library item is the class. lib1 colon double colon net server. It means lib1 is an object of a class called net server, and it starts from, as you can see, it's an order. Start from library user lookup, and then to the ACAT. Then the ACAT returns display the result to the library user. Then the library user issue by requesting the library item, and so on. Here you can see it's the order. We can see the order. So the order of function that should be executed in order to issue an electronic items is gonna be like this. First lookup, then display, issue license, accept license, compress, and deliver. This is the order that should be executed in order to issue an electronic item. This is an example of sequence diagram. The example represents the ATM deposit transaction. As you can see, we have three objects. We considered the actor object. We have actor, we have an object for ATM, and the object for the bank. The actor, it might be a customer or a bank customer, let's say, or a user. When we need to deposit through the ATM, we need to insert the card to the ATM. Then the ATM needs to check if the card is valid or invalid. Here in the sequence diagram, there's a method or a function that might has an exception, such as, for example, here the card, it might be valid or invalid. We need to model or to let's say handle the error or the exception before going on. As you can see here, if the card is invalid, we need to notify the actor. If it is valid, we go to the next below it. This just keeping your mind if there's a function or method, and this method could lead to an error or exception, we need to handle the exception before going on. And as you can see, down to the pin, like imagine we assume the valid code for the card is correct. Then the ATM requests pin. The user or the actor insert the pin. The pin is verified by the bank, and if the pin is invalid, we need to notify the user. If the pin is okay, then we give the user the option menu. The user or the actor select the deposit. Then the ATM requests to specify or to enter the amount, and insert an envelope requirement. Then the actor or the customer send the envelope to the ATM. Then the ATM call the bank object to add the amount. Then we need to change the balance and give it to the actor. Then the ATM requests the actor to take the card. If the actor or the customer didn't take the card is gonna be swallowed. If the actor took the card is gonna be removed and finally display the welcome message. here you can show the order. See, we just this is another example about ATM, but the operation here is now withdrawal, the withdrawal transaction to withdraw money. It's gonna be the same, but we need to just request some cash to withdraw.